Small angle prism. That's why we are using that particular formula. Yeah. Next problem. The path of ray of light passing through an equilateral prism ABC, there's a prism is there, is as shown. The ray of light is first incident on the face AB, then undergo TIR at face BC and emerges out from the face AC. Okay, the net deviation produced by the prism is 108 degrees. This is incident ray, this is emergent ray. You have to calculate the refractive index of material of the prism. He has given some information, sine 24 is equal to 0.4 degrees. Okay, let's start with this is a normal, this is a normal, this is a normal. Okay, agreed. So let this be the angle of incidence, I1. This will be R1, R2, R2. Let this be R3. Let this be I3. So deviation, it will n it will undergo TIR here. Here undergoes TIR. So if it undergoes TIR, it will act like a reflecting surface. Angle of incidence should be equal to angle of reflection. Now we have to calculate the mu of a prism. What should be the approach? Way to bring the mu. Okay, let's get into some relationship between the angles. Now, it's a equilateral prism, so therefore this angle 60 degrees, 60 degrees, 60 degrees. Then if you equate the so carefully, so let me expand the diagram. You can see all the things. So this angle, let it be alpha. So now, are you seeing this one cyclic quadrilateral? M, B, N, say some symbol here. Then also one more cyclic quadrilateral, O, C, N, and this particular point. So in cyclic quadrilateral, the sum of opposite angles should be 180. So 60 plus, this is a solution, 60 degrees, some cyclic quadrilateral. So 60 degree plus alpha equal to 180. So alpha is equal to how much? 120 degrees. Then from the triangle, this triangle, and some symbol I'm unable to write it because the space is not there, and you call say some P M in this triangle. Sum of angles will be R1 plus R2 plus alpha equal to 180 degrees. Alpha is 120. Similarly, in the quadrilateral, 60 plus beta equal to 180 degrees, beta equal to 120 degrees. Then triangle, here, this cyclic quadrilateral. Sum of opposite angles should be 180. Then in this triangle, beta plus R3 plus R2. So therefore, equating these two, from 192 what we can write R1 equal to R3. If R1 equal to R3, then sine I1 equal to mu sine R1. So therefore, I1 is also equal to I3. Okay, these are some important conclusions we have. Okay, then let's take help of this deviation. So the net deviation should be equal to deviation at M and O. The total deviation suffered by the ray at M and O should be equal to sum of deviation at M and O. So the net deviation at M will be I1 minus R1. Deviation here, this is the angle. The ray wanted to, incident ray wanted to go straight if there were no prism. But due to refraction at M, it took path like this. So what is the deviation? I minus R1. If a ray moves from brighter to denser, the deviation will be angle of incidence minus angle of refraction. Then it wanted to traverse path like this. So it got reflected. So this is the deviation, 180 minus 2R2. Deviation at O. So the ray moving from denser to rarer, then angle of refraction minus angle of emergent should be the deviating angle. So this will be R3 minus R2. We know R1 is equal to R3, I1 equal to I3. So 2I1 minus 2R1 plus 180 degrees, or say 2R2 minus plus 180 degrees minus 2R2. R1 equal to R3. Yeah? Okay, it will cancel out. This will not be there. Since R1 equal to R3, so minus 2R2 plus 180. R1 equal to R3. R1 equal to minus R1 plus R3 will cancel out. Minus 2R2, 180. So I1 equal to I3 will get here. We know what is other information is asking to get the material of the prism. How to solve further. So some I1 and so we will take help of this condition. R1 plus R2 equal to 60 degrees. So here R1 equal to 60 minus R2. Here looking at this one. Already we had no R1 plus R2 60 degrees. So let me take sine on both sides. Sine R1. Okay, let it be here. Sine R2 should be equal to 1 by mu. From where I brought this equation? Because the ray will undergo TIR here. So sine of critical angle should be equal to 1 by mu. Okay, this equation I brought it. Now we have to get expression for mu. So mu will come sine I1 equal to mu sine R1. So I should replace R2 I got it. Okay, let me take help of this equation. So sine R1, yes, let me explain now. Sine R1 equal to sine 60 cos R2 minus, so sine R1 equal to root 3 by 2. Cos R2 will be root of, I will write it somewhere here. It will, I'll scroll down. We'll move further. This is one part of discussion. Let me continue. Sine R1 sin R1 equal to sine of 60 minus R2. Expanding this, sine 60 cos R2 sin R2. Then this will be cos R2, so this will be 1 by 2. Sin R2 is 1 by mu. So sin R1 equal to root 3 by 2. Okay. But we wanted mu, no? Okay, somewhere we have reached mu. Sine I1 deviation we know. So I1 and R2. So somehow I think I should get the. We have information of R1 plus R2, no? Yes. I1 is needed, no? I1, can I find out? R2, I need a lot of place here. Yeah. We have to calculate this I1. Huh? Oh, 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 oh. I will rewrite this. I1. This will be R1 plus R2 plus 180. This one R2 I'll split up. R2 plus 1, R1 plus R2 is 1. Another R2 and R3. Minus R2 plus R3. Here, this went from I3 minus R3. Oh, okay, no. Angle of emergence minus angle of incidence. That should be. So I1 equal to I3. So 2 I1. So one R1 and R2. R1 plus R2. Other R2 and R3 will get here. Okay, fine. 2 I1. R1 plus R2 is 60 plus 180. R2 plus R3 is also 60. Deviation how much given? 108 degrees. 108 degrees 2 I1 This will be 60 degrees plus 60 degrees. 48, 24. So I1 equal to 24 degrees. After getting I1, now R1 is needed. Okay, fine. So much of calculation. I don't have place here. I'll come back to this equation. So this will be sine R1 to 3 by 2 mu square by minus 1 minus 2 mu. Then we'll apply the Snell's law. Sine I1 equal to mu sine I1. Sine I1 sine 24 degrees equal to mu. So solving this, here mu will get cancelled. Sine 24 degrees we know. So solving will get the mu. I need place. I'll just think so. Okay. Let me this. Yeah. Okay. Now we have. Yeah, I can show all the things now. So sine 24 degrees equal to root 3 by 2. Solving now. Mu is only unknown thing. So I think if you see the breakup here, this part, something relationship between the angles. Let me shade it. This is some relationship between the angles. Okay, this is all about the deviation one. You see, the problem is very beautiful, where the student has to apply so many concepts. And that's why I just picked up this problem. Okay, this is about the deviation one. What is the deviation thing? When a ray moves from rare to denser, angle of incidence minus angle of refraction. It gets reflected. So 180 minus 2R2. When a ray moves from denser to rarer, angle of emergence minus angle of refraction. Now this R1 plus 1 minus R1 minus R2. Minus R2 minus R3. It is adjusted. R2 plus R3 again we have here. 60 degrees. R1 plus R2 60 degrees. That is substituted here. Okay. Solving will get I1. Then this is about the other part. From where this is brought, sine R1 equal to, again I took help of this equation. R1 plus R2 60 degrees. So R2 R1 is equal to 60 minus R2. I'll apply sine on both sides. Then we have started here. Hope I'll bring all the things. Yeah, you will not get confused at least. Screen, I have very less space on the screen. That's why. Oh, oh. Yeah, you have everything at one place. Huh? So solving this will get expression from you. Calculation, I will leave it to student. The mu value is what I'll give it. You check it. At least you have to do calculation part. Don't ask teacher to solve this also. 1.447. This will be our answer. Hmm? Able to understand? So whenever the prism problem comes, so you focus more on things like this. Huh? Okay, C11 complete view. Then I'll go to the next problem. Read this question.